In the remaining weeks of the class, we will spend our time solving systems of differential equations. Our first method involves us solving linear systems using Laplace transforms, and it's a pretty straightforward process compared to some of the other processes. However, it's going to also be very tedious, so it's going to be probably broken down into a 3 or 4 part video series depending on how many steps we show. So the first thing we always do is go through and take the Laplace transform of both of the differential equations. So if we take the Laplace transform of the first one, we end up with s times capital X of s minus little x of 0. And that is equal to Laplace of the right side, which is negative capital X of s plus capital Y of s. For the second equation, we're going to have s times big Y of s minus, well, that's not very good, minus little y of 0. And that's equal to 2 times capital X of s. We'll next substitute in our initial conditions. The first initial condition, well, that's just equal to 0 for x0. And then for the second one, that's equal to 1. So that takes us to s times capital X of s is equal to negative capital X of s plus y of s. For the second one, sy of s minus 1 is equal to 2 capital X of s. And the next thing we're going to do is now go in and we're going to write this in a matrix form. First step of that, of course, is to bring all of the capital X's and Y's to the left-hand side and bring all of the non-capitals to the other side. So what we're going to do then is go in and move these things around a little bit. So we're going to have s capital X of s, and then plus capital X of s minus big Y of s is equal to 0. And then we're going to have negative 2x of s plus s big Y of s, and that's going to be equal to a 1 on the right-hand side. The next thing we'll do is write this in a factored form. So this is s plus 1 x of s plus negative 1 times y of s is equal to 0. Negative 2 x of s plus s big Y of s is equal to 1. And then our next step is going to be to write this in matrix form. So the matrix is going to be a 2 by 2 matrix of coefficients. So we'll have an s plus 1 coming from the capital X of s. A negative 1 is the coefficient on the big Y of s. A negative 2 as a coefficient on big X, and an s as a coefficient on big Y, times the two unknowns, capital X of s, capital Y of s, is equal to our right-hand side as a 2 by 1 vector, 0, 1. And so we have this written again as a 2 by 2 matrix times a 2 by 1 column vector is equal to a 2 by 1 column vector. In our next step, we'll go through and use Cramer's rule, which uses determinants to go through and actually solve this system for big X and big Y.